Okay, hey guys and gals, hopefully you all are doing well. We're getting into week 2 now of our coronavirus virtual learning, learn from home, whatever we want to call this. We've got a little bit more information now about the AP exam. Certainly that's coming up. The AP micro test is coming up here pretty quick. One of the downsides, there's still a lot of material that actually is going to be covered on the AP test that we haven't gotten to yet. The good thing is we've actually covered quite a bit, but there's still quite a bit to get to, and so I wanted to start making a few more videos, posting a little bit more frequently. But before we get to the one today, okay, before we get to this particular one, I want you to go ahead, either stop the video, pause the video. I want you to go back to the video that you guys, I think it was the first one I did, that was the wrap up on the cost of production. I had the cost of production table up here with the different numbers. Go ahead, pause this video, go back to that one, and watch that one again, because today what we're going to be doing is taking the numbers and taking the patterns from that video and putting them into actual cost curves now on a graph. So it's really important that you kind of get some of the conceptual stuff in the cost tables before we turn it into a graph, and then we're going to kind of build on that over the next couple of videos. So I'm going to keep this first one pretty short today. And then we'll move on to some more complicated ones here over the next week. All right, so the first thing that I want to do real quickly is kind of set up the graph a little bit. We're always going to have our dollars over here. Now in this case, it's going to be cost as opposed to price, but it's still basically the same thing. The only difference, cost is what a company pays, price is what we as consumers pay. So it's still the dollar figure that is going to be on the vertical axis. Over here, it's still going to be the quantity, the number of goods produced. Nothing's really changed in terms of that. So the first curve that we're going to look at, okay, the very first curve that we're going to take a look at here is going to be the marginal cost curve. The marginal cost curve, we're basically going to draw the Nike swoosh, okay? We're going to draw a big check mark to represent marginal cost. So essentially this guy right here, that's our marginal cost, okay? Put MC up here. Now, it's important for you to understand the reason why the MC curve is shaped like this. First off, initially, the MC curve is going down. Okay, initially MC is going down. The reason that the marginal cost initially goes downward is specialization. The cost per unit is going down due to specialization. So we talked about, like in a taco shack, that your first couple of employees, as you're hiring new employees, they're able to essentially produce more, and your cost per unit is going down because they're able to specialize in different things. Maybe you have one person cooking meat on a grill. Maybe you have another person that's handling the customers and making change. You have another person that is assembling everything. That's specialization, and we start seeing the marginal cost go down due to that. Eventually what happens is we hire more and more workers in a confined space, and we get the diminishing marginal returns. Too many cooks in the kitchen. Once that happens, the MC, or the cost of each additional unit, starts going up, and it goes up continuously unless we were to get added space. If we had a taco shack, maybe we get a second one, or we add on to our space. We spread out the workers more. But absent of that, this is always the shape that we would see for the MC. Okay, so that's our first curve. Second curve that we're going to show up here is going to be our ATC, our average total cost. Now this is going to look like a big parabola, okay? Basically a big upside down umbrella, so to speak, or a big U shape. But this is the important point. What I want you to do is just pick any random point on the MC curve. Okay, I'm going to pick a point like maybe there. And you're going to pick that as your minimum. So you're going to essentially have that as the bottom of the ATC. So we'll go up like this, and then we'll go up on the other side like this. This is going to be our ATC. Now the reason that is the ATC, the reason that the shape is like that, our average total cost initially going down due to specialization, eventually going up due to diminishing marginal returns. But here's the reason that it intersects at this particular point, or rather that the intersection happens at the lowest point of ATC. The MC basically drives the ATC. This is sort of the cause of this. And the best way I can think of to explain it is think of your MC, think of your marginal cost as like your current semester's GPA. Okay, the GPA of what you're working on right now this semester. The ATC, I want you to think about this like it's your cumulative GPA. All right. So for those of you that are seniors, which is I think most of you right now, this is this one semester GPA. The ATC, man, we've got 7 semesters behind it that have contributed to this GPA, to this cumulative GPA. So if let's say your overall GPA, your cum is let's say a 3.5 unweighted, all right? If that's the case, you got a 3.5 unweighted. If your current semester GPA is let's say a 3.8, what's going to happen to your overall cum? It's going to go up. Your semester GPA is higher than your cum goes up. If your MC is higher than your ATC goes up. But if it's below, let's say we got that same 3.5 cumulative GPA and this semester you only get, let's say, a 3.0. What's going to happen to that 3.5 cum? It starts going down. So anytime the MC is below the ATC is going down. That's essentially how that works. Okay, now we've got 2 other cost curves we've got to throw in. The first one is going to be our AFC, okay? AFC, average fixed cost. An average fixed cost, hopefully you guys got on the table, always going down. You're always taking a fixed cost, which is the same, you're dividing it by a greater number, so AFC is always going down. So we're going to pick any sort of random spot here. The only thing is it can't be above the ATC, okay? So any point below the ATC, probably fairly high. We'll pick something like maybe up here, something like that. And we're going to have it go steadily down, and it's going to approach the horizontal axis. It's never actually going to touch the horizontal axis, okay? So it'll approach it but not touch it. And that's going to be our AFC, average fixed cost, okay? Now, one last one then we've got is the other component of ATC. That is our average variable cost, or AVC. If you remember at the very end of the cost of production tables, right before we sort of got sent home, we talked about the fact that ATC, there's 2 different ways we can calculate it. We can do TC, or total cost, divided by Q. Or if you're like me, I'm more of an addition subtraction kind of guy, okay? I'm not smarter than the average bear. So I like addition subtraction. So for me, I like doing AFC plus AVC. So in this, we're going to basically sum up these 2 curves. Our AFC and our AVC are going to equal our ATC. What that means is, since this is pretty close, since our AFC at the start is pretty close to our ATC has got to be about that same level above the horizontal. In other words, if these 2 were close together, then this has got to be low, and I'll explain that again in a second. This is going to have the same basic shape as the MC curve. AVC and MC are going to have the same basic shape. It's going to go down a little bit, and then it's going to come up, and it's going to get pretty close, okay? In fact, yeah, it's going to get real close, okay? We'll make it even closer. We'll call that there AVC. Here's the concept. Because these 2 curves, because the AFC and the AVC, if you add the 2 of them together, they equal the ATC. When the AFC is larger, okay, these 2 curves, ATC and AVC, have to be further apart. And you go, well, wait, why is that? What are we talking about here? Well, if let's say, I'll put it over here, if ATC equals AFC plus AVC, okay, then ATC minus AFC has to equal our AVC, right? So when these 2 right here are close together, this has got to be pretty low. When these 2 are far apart, this has got to be pretty high, okay? Another way of looking at it is to say, all right, if we did our ATC minus AVC is equal to our AFC, if you want to look at it that way, okay? So when that number is low, when that distance is very low, AFC is very low. When that distance is far apart, when that number right there is much greater, because it's a much greater difference, AFC is going to be much higher, okay? So basically the distance between these two curves, between that blue and that red curve, have got to be the same as the distance that this green curve is above the horizontal axis, okay? Now, that's probably going to take a little bit of time to digest, okay? So I'm going to leave off there. Go back, feel free to watch this once or twice. I'm going to have office hours on Thursday and Friday. There's no requirement to join, okay, but I'm going to send out an invite on Google Classroom to join on Google Meet. No requirement, but if you would like to join, certainly feel free to hop in. I'll be in for 30 minutes, 40 minutes, whatever. Or you can always email me questions or put questions on the bottom in the comments, any of that. But I'm going to leave off there. Feel free to go back, watch this a time or two, and then we'll pick it up there next time.